Hi everyone, and welcome to OpenMined AMA. Ask Me Anything. OpenMined is an open source community focused on making the world more privacy preserving. In this AMA interview, you'll have the opportunity to ask questions of privacy experts from OpenMined community. My name is Amel Sellami, and I will be your host for the day. First, let's introduce our guest for today, who is Alan. Alan, welcome. Alan is leading the Hi, Alan. So Alan is leading the NLP team at OpenMind, focusing on building CipherText, a privacy-preserving NLP library. He obtained a PhD in computer vision from Télécom Bretagne in France, and he's currently the head of computer vision at the Contillery, a Parisian startup aiming at providing quantitative metrics for evaluating the engaging power of visual social advertisement content. He is passionate about studying the role of visual attention in video action recognition, a project he has started as a postdoctoral researcher at the Collège de France in 2018. Welcome again, Alan.
Thank you. Thank you for having me here, Amel.
Thank you. Great. Yeah. So I think first of all, let's start with the presentation that you have prepared for us today. And then we'll go ahead and ask the questions that you can submit in the comments or in the Slido part. Thank you for joining. Okay.
Thank you, Amel. Okay, so let's share the screen maybe. Perfect. I can see the screen now. Okay, thank you. Maybe I will just check out if the pointer, yeah. So thank you again, Amel, for having me here, and thank you everyone for watching this talk. I hope it will be instructive for you. It will allow you to learn a bit more about what we are doing in at the NLP team at OpenMind. So as Amel said, I'm leading the NLP team here, and we are mainly developing CipherText, which is the main, let's say, product or project we are currently focused on. So this is, let me tell you a little bit about like let's say the history of CipherText. So it's a pretty young project. We started it, it was like after some discussions in the crypto team at OpenMind. So we decided to create an NLP library that is built on top of PySift. For you who know PySift, who do not know PySift, this is the library OpenMind is creating to provide tools and APIs to enable federated learning, for instance, secure multi-party encryption or encrypted computation in general, and other support for other libraries that are coming. So this is a pretty young library, as I said. It's open source, so any one of you who is interested actually can contribute to this, to the code source. Of course, I'm not developing this alone. I'm developing this with the members of the team you can see on the screen, and also some other contributors that are coming from all around the world. So I would really like to thank all of these contributors, and especially my team members, for the amazing work they have been doing for the last few months, and the great motivation they were providing for all the community interested about NLP. So this presentation, actually, it will be divided in like two parts. The first part will be more a higher level presentation about CipherText, the library I'm going to explain, to talk about. So it will be on about like flowcharts and like higher level schemas for you to understand what is it about. And the second part, I will be showing you some code. So delve into more like technical stuff and to show you how we can use CipherText with the help of PySift, of course, to create a sentiment classifier that can handle multiple data sets that are private, so that we cannot access, actually we cannot see, to be able to use them to train your model without any violation of data constraints.
Cool.
So let's start. So what is exactly CipherText? So why we are building CipherText, what for? So I thought about two main usage cases, so two main ways or reasons why CipherText should be used. So the first one is to perform secure plain text preprocessing. Of course, here we are talking about the case where the datasets, the text datasets, are remote. They are on another machine, let's say it like this. For instance, if you are working with multiple hospitals, each hospital might have its NLP, or sorry, text dataset that you wish to preprocess, but due to some constraints, such as the GDPR in Europe, I think the HIPAA in parts of the United States, you cannot actually transfer the data to your machine, your company. You cannot do centralized deep learning. So you need a way to send some remote computation to where the data live and start doing preprocessing on it. And the other reason why CipherText is used is to, like, once you build your pre-processing pipeline, you create your deep learning models with PySift, you need a way to encapsulate the whole pipeline of pre-processing and processing, so computation, and to provide it as a service. So everyone, the people you identify as authorized to use that model should be able to use it. So CipherText is also used for such deployment. So here's, I'm going to explain the first usage case, so pre-processing. So in order for you to, let's say, understand why NLP has some special treatment, why we are building a special library for NLP, for instance, and not for computer vision for the moment, because images, we can consider actually that the native format of images, of like the way to present images is as pixels, and pixels are also represented as numbers. So in order to hold a data set of images, we can imagine that we will have just like a group of tensors, vectors, or matrices, if you want. So this means that once you have images, you can just do any pre-processing and any transformation on them just using tensor operations. So PySift for the moment is completely adapted to this. We can manipulate any tensor that is remote or local. This is perfectly ready in PySift today. When we talk about NLP, we talk about datasets that are text. And actually, text, we cannot use text, let's say, out of the box in a deep learning model. You cannot just feed the plain text into a PySift model or any deep learning model. Normally, we need to do some pre-processing in order to transform a string into tensor. So in NLP, we call this, for instance, creating embeddings, vector embeddings of words or documents, or any group of plain text strings. So this is the first usage case of CipherText, and actually this is the usage case I'm going to show you the tutorial about today. So as you see here, CipherText will allow you to create some pre-processing modules, for instance, tokenizer, parsers, and taggers, and maybe you would like to tag to pad some vectors or something like this. So you can define this in CipherText. You can send these computation modules to operate remotely on the plain text string. So you won't see the string. All the pre-processing will happen on the remote machine. It will be transformed into tensor, and then you will be able to create a deep learning model to manipulate these tensors and to be trained on them, for instance, to create a sentiment classifier. So once you create your pipeline of pre-processing, so imagine you send some pre-processing modules here, and then you train the sentiment classifier. So you can consider that the tokenizer here and the parsers, along with the model here, it's a pipeline of of computation that you need to apply to a string. So this is something you would like to deploy actually for people to use. So here's the second usage case of CipherText. You will deploy this whole pipeline of computation, let's say on your machine as a company. And now if there are like many other organizations or like many users on their phones, they have strings that are private. They don't want to share it to you direct, like to send it to any other machine because it's private. They can just use CipherText actually to search for a pipeline defined by a name, like for instance, like a sentiment classifier, cancer detector, for instance, cancer classifier. Just search for it, and CipherText actually will handle the way this pipeline should be broken into pre-processing part that should be sent, for instance, and a model that should not be sent. We might want not to send it to the remote device because the model itself, in some cases, can be private. Means that as a company, you don't want to send your model because the worker or the client might be curious, might be malicious, actually. So we would be able to handle such cases. So these are the two usage cases. Now, who are the people or the persons or the roles that are going to use CipherText? So two potential users here. So the data scientist, so you as, let's say, deep learning expert, an NLP expert, you will be able to use CipherText to create these pre-processing pipelines, then to train a PySift model, then to bundle it and to deploy it. So this is the role of a data scientist or a data owner. So imagine you are a hospital, you have your data set and you are sitting on your machine and you know, like there is a deployed model somewhere on PyGrid, which is the network of secure workers we are working on at OpenMind. You can just import, actually, use CipherText to use this deployed model as I showed you. So let me show you a little bit more about how these interactions between workers are supposed to work.
Happen.
Yeah, happen. So the first user is the data scientist, as I mentioned a few minutes ago. And of course, the first thing you would like to do normally is to train a model, which is the use case I'm going to show you in the tutorial in the second part of this talk. So you are a company, and there are two machines, like remote machines, remote clients, Bob and Alice. Both Bob and Alice have strings or text data sets, and you want to train a model on both data sets, but in, let's say, concurrent training. It means that as if both data sets were a single data set. Well, in a privacy, in a constrained or private environment, you want to be able just to transfer these strings into your machine and like create a bigger data set and then train on this bigger data set to create a better model. Because, you know, like in deep learning, in many cases, actually, more data means that you will be able to get better performance. For like, I cannot say in all cases, but this is like in many cases, majority of cases, we would like to get better, like more data, more versatile data. So in order to be able to do this, even if data is private and without violating this privacy, as I mentioned, we can use CipherText. So the data scientist can use it. So here, this is equivalent to saying that in Python, actually, you import CipherText, use CipherText, and you start creating your pre-processing pipeline. This is why I just written this create function method. So we create what we call language model. So for those of you who are familiar with Spacey, which is the amazing NLP library, you will find many similarities in the API between CipherText and Spacey, because CipherText actually, we were inspired by the really great API of Spacey to to provide very similar functionalities, how to interact with it. So if you are familiar with the space, you will be familiar with the way how to use CipherText. So you create this language model, and this language model actually, you will add to it all the like pre-processing components. So you define a tokenizer, you define like a tagger, polar word tagger. It's not very important now, the details, why I call it stop tagger or polar word, and just like pre-processing components. You define them on your machine, actually. And you define, of course, a deep learning model that you would like to train. And then PySift actually provides the possibilities to create tensors and objects, for instance, strings, and also it allows you to create pointers to strings. So if the string is remote, it lives remotely, it doesn't mean that you cannot manipulate it. It just means that you cannot see its contents or transfer its content to your machine if it's restricted, but you can still send some commands to it. So this is what we call a remote object. Yeah, so here, once you create your pre-processing pipeline, you just need to call this pipeline to operate, like to start pre-processing. And once CipherText recognizes that your string is actually a pointer to a string, it's not a real string, it starts to do all, sorry for that. So it starts to do all the work behind the scene to break the pre-processing pipeline into multiple sub-pipelines to send each part to a different worker, and to do pre-processing locally on that worker, and then to create what we call doc object, which is the object that contains all the tokenized individual words that were included in that string, and all the tags that you associate with it, all the pre-processing stuff you did in it. And then using special functions, you will be able to get these numerical representations encrypted, because we cannot reveal even the numerical representation. So you can encrypt this tensor and get it to your machine, and to put it in a like matrix of vector of numbers, so what we call a training batch, and to train your model. So this is like kind of complicated schema, but this is something that CipherText handles behind the scene. As a data scientist, actually, you will feel that you are working on local data. You will feel as if you are just manipulating a string, which in reality is just a pointer to a string. And you feel that you are tokenizing it and creating the batch and eventually the model. So once you train this model, as I mentioned earlier, you create this pipeline of computation and you deploy it, you save it on your company's machine. And of course, many companies can do the same. And many, like each company, of course, can create different pipelines of computations, what you see here. And all the workers or the clients and the companies are eventually connected with what we call PyGrid. So I mentioned this also earlier. This is also a library developed by the OpenMind community, which can connect these machines, let's say hospitals and companies, in a secure network over which PySift and SyferText and other libraries can operate. So you deploy this model, and then let's say you are a data owner, and now this is the second user case. So as a data owner, you can search for a model. So I just put here like very little, like pipeline 2, pipeline 1, pipeline. Like these will be like names of computations, as I mentioned, like cancer detectors, sentiment classifiers, whatever. And you will use CipherText to search for the name of the pipeline you want. Let's say you are Bob, and this is the company, and you find your model. This is sentiment classifier model, and you have a private string. And here I show you a little bit more in detail how CipherText will act in this case. So you import CipherText. So CipherText will automatically detect that, oh, sorry for this. So you will use the load function here to search for the language model. And once you find it, CipherText will recognize that there is a pre-processing part. And it will recognize, due to some permission parameters that you configure, that the model should not be downloaded and used locally on your machine. It should be used as a cloud service, let's say, remote inference service. So here I write inference, and then it will break the pipeline into two sub-pipelines, pre-processing and processing and prediction part. And the string will be fed into, like, first the pre-processing pipeline, the doc object will be created, and then the other prediction pipeline knows that it can pull the encrypted document from the local document using what we call document pointer. So we in PySift and CipherText, and actually the way the libraries we are developing work is like you manipulate objects using their pointers. So you pull the encrypted vector, and actually you don't, like, CipherText will pull that, and it will be encrypted, of course. You will see only the encrypted version. Prediction will be like the feed-forward inference pass will be performed, and then you will get the encrypted prediction, and through that pointer you can send the prediction back to the doc object and store it inside, and then Bob will be able to encrypt this result because he has the right to do it. So this is the data owner point of view of using CipherText. So let me summarize a little bit. So CipherText, two usage cases for pre-processing and deployment, and two user cases, or two potential users, a data scientist to train and deploy, and the data owner who can use the deployed model to do inference.
Yeah, seems very clear.
Perfect. By the way, if you have any questions, maybe you are already asking questions, but like just ask questions and I will answer them after this talk, but like feel free to start if anything is unclear. Now, actually, one thing I think very interesting when we start to create libraries that implement or allows us to create deep learning models in a real private setting. Like, I mean, you really have the remote pre-processing like in a production setting, production context. It's very interesting in my opinion, because I read many interesting papers today about, for instance, NLP or in other domains too, who talk about creating federated learning, especially in NLP actually. So what you do normally, because we do not have yet this facility to do like remote pre-processing and like encryption, we will pre-process the data locally and prepare the data set locally in many cases, or we will look at the data because it will be simulated case, simulated federated learning setting. And then what you will evaluate is just the performance, the accuracy of the model, like how good this classifier is. But in my opinion, it's very interesting because when you have a distributed environment, it's not only about how accurate your model is, it's also what is the network latency, how quick your pre-processing is actually, what is the efficiency of the algorithms you're using for pre-processing, and how is this impacting the whole training cycle actually. So in my opinion, with tools such as PySift and CipherText, you will be able to do your research in the production context and to deliver or provide your evaluation metrics, not only about performance, but also about the whole system. Is it efficient? Is it realistic to go that direction? In many cases, maybe it won't be realistic, even if you will have very performant model, let's say.
Yeah.
So, yeah. So now that you have the higher level picture of CipherText, let's delve a bit deeper into some code details. So I will show you how to train a sentiment classifier using PySift and CipherText. A very important note, actually, CipherText is not the library to train a model. Training a model or creating a model is PySift. CipherText is for pre-processing and bundling what you train with PySift. It's not a deep learning library in the sense when we talk about like PySift, PyTorch, TensorFlow. It's these like two usage cases I talked about. So here we will suppose that we have two, let's say, devices, remote devices. They have movie reviews. So I'm using the IMDb movie review dataset, which has sentences like that describe a movie, how good it is, or how bad, for instance. And there's a label, like, is it positive review or negative review? And we will consider that this is a private data set. So we will break this data set into two parts and put one on Bob's machine and the other one on Alice's machine. And then consider that we want to train a classifier of that sentiment on both data sets at the same time to create a bigger data set, which is a very interesting use case, to be able to create bigger data set out of small distributed data sets, which won't be possible if you don't have these privacy preserving tools that PySift provide us with. So let me show you how the data set looks like. So Bob and Alice, as you saw earlier, are PySift workers. We call them workers, but you can think of them as devices, your mobile phone, your hospital, your whatever. And each review is represented by an object. Actually, it's a PySift object called string. And the label is a tensor because it's a number. And so you put all the data set in dictionary, for instance, like data structure on Bob and on Alice. And locally, as a company, you will be able to search for this data set and to retrieve a data set locally that won't contain the strings. As I explained, it will contain, here I represent it as a dictionary. So each example, training example, is dictionary. The review holds what we call a string pointer, so it points to the real string, and the label is a tensor pointer, which points to the label. You have many of this for Bob and many of those for Alice. And just remember these two variable names, train Bob and train Alice, which are the data set for Bob and data set local representation for Alice. And also, like, there's no privacy violation because you don't see the data. Now, the important step where we will use CipherText is secure pre-processing, where we will create the pre-processing pipeline I showed you earlier. Just we are going to see it in code. So 4 major steps here. We create the language model, so the CipherText language model, or the language class. This is the object to which you add all the pipeline components. Then you define the tokenizer and the taggers and all the pre-processing parts. You add them to your language class or your language object. And then you create the class or the object that will trigger this pre-processing pipeline. like orchestrates this processing pipeline and like triggers it for execution. So for those of you who are familiar with PyTorch, here when I say dataset class, I mean the dataset you usually load into the data loader. So let's begin. So you import CipherText as a data scientist here, of course. And I'm not going to show you all the imports we need here, not to clutter the screen. So you import CipherText and you load a language model. So soon this will be create actually, but if you like follow the evolution of CipherText in the few coming weeks, this will be changed a little bit. So you load language model. So if you are, again, familiar with Spacy, this is also adapted from Spacy for our experimentations. So it's a language model that only holds the vector embeddings that represent the words. So each word has a representation as a vector here, and we will use it off the shelf. We're not going to create our embeddings here. So notice that this returns the NLP variable here, which is the language object I was talking about. And here we should specify that we are, as a company, the owners for the moment of this language model. And here me, actually, this is a PySift object that represents a remote machine, or in this case, it's our local machine, but it can represent a machine. I mean, it can be remote or local. Of course, I don't show you the imports that are necessary to create this part, but if you follow the tutorial I prepared, the Jupyter Notebook, you will be able to see all the details, and you will be able also to run the training, actually. So now we create the pre-processing parts. I don't create explicitly the tokenizer here, because the tokenizer in this version of CipherText I'm showing you is created by default. This might change a little bit in the coming weeks. So what I create here are two objects that are of the simple tagger class. So this is a CipherText class that I don't show you how to import here, but like just keep in mind, it's a CipherText class. What I do very simply, because I'm classifying sentiments, I just want, after the tokenization, separating the phrase into words, I want CipherText to use the simple tagger object first to exclude all the stop words which are neutral if we talk about sentiments. For instance, the, is, I mean, all the words that are not, like, we call them stop words.
Yeah,
exactly. Yeah, so they don't change.
Don't have a sentiment in it. Yeah,
exactly. So we exclude them because we don't want to introduce any noise in the vectors that will represent the documents. So this tagger will check each word. If it's stop word, it will give it an attribute is called, in this case, is stop. So the list of stop words I stored in this is a list. I don't show you the content, but it's like, just imagine that it's a list of stop words. If it's stop word, it gives the value is stop equal true. If it's not true, it gives it is stop equal false. And this is case insensitive comparison. We don't care about cases. The other tagger I show you here is about polarity of words. So we can actually get some lists about what's the polarity of each word. For instance, the word wonderful will be considered as positively polarized or polar, which is, we would expect that it will be associated to positive sentiment in most cases, and maybe bad, awful, or those will be associated to bad sentiments. So we will give each word that is tokenized is polar attribute, true if it's polar, and false if it's not. So remember these two objects, stop tagger and polarity tagger. These are two pre-processing objects that we will use. Now, just very important variable here, which I call excluded tokens. It means that the tokens that have is stop true, which are stop words, and is polar false, which are not polar, we won't care about them. We will just like exclude them from the whole pre-processing, and you will see where this will happen. Now we simply add the stop tagger after giving it a name. So I give it stop tagger name also. We add it to this language object. Like we start to create our pipeline. We add first the stop tagger and then the polarity tagger. Of course, here you can think that a polarity tagger alone is sufficient actually, because it should exclude all the stop tagger, the stop words, which is true, but this is just for the sake of the tutorial. And a very important parameter, remote true, which means that once CipherText encounters this component and it knows that it's allowed to be remote, it means that if the string is remote, it lives on a remote worker, CipherText will have the right to send it there to operate there. And now we start creating the dataset object. The dataset here, the class dataset, is a PyTorch object or PySift object in our case, because PySift is the library that encapsulates PyTorch in our case. So this is class objects of this class will operate the pipeline for preprocessing. It will send the command to start preprocessing. So here, very quickly, I will show you, we passed the sets. You remember train Bob and train Alice, the data set that hold the pointers to the strings. Here, because we are going to do encrypted training, so the vectors, as I mentioned, will be created, and the model too will be created, the deep learning model with PySift. And we will use encryption scheme called secure multi-party encryption. I'm not going into the details of this, but you need actually to tell it which are the workers that will hold the encryption shares. And then, of course, the two data sets that you pass, I use this method to create a single big data set out of them. So I mix only the pointers. So I'm not mixing the real data set, I'm mixing the pointers, which will be an abstraction of two data sets as one big data set. And of course, the CipherText object that we call NLP that has the pre-processing pipeline. And here the key method in the dataset object, which takes one example. It passes it through the pipeline. We added the pre-processing pipeline we added as the NLP in the NLP object. And it returns a document pointer, as I showed you earlier. And then on that document pointer that you hold locally, you call a method getEncryptedVector. So it will encrypt the vectors using SMPC. I'm not going into the detail of this. If you follow the tutorials on PySift and CipherText, you will learn more about this. But the important thing here to notice is that I pass also the exclude tokens here. So when we create the encrypted vector of the document, we exclude these words that we don't want. We do the same to encrypt the labels. Of course, not with CipherText, only with encrypting, because they are already tokens. We don't need to pre-process labels. They are already numerical tensors, I mean. And this is exactly what I did in code here very quickly. Like you created the language model, you added the tokenizers and the taggers, you created doc object, and you have the pointer to doc, you call the getEncryptedVector, and you start creating batches and training. And now finally, this is a very quick step. So if you have already created like deep learning models with PyTorch, you will find this very familiar. Actually, nothing changes. The different part was only to create this CipherText pipeline. So here you instantiate two dataset objects for training and for validation. And notice I pass my NLP language model. The train loaders, which will call this pipeline each time, and to get you one training example as a vector, of course. And the classifier. So here we use PySift actually over PyTorch. So you feel, if you use it actually, it feels that, like you are using PyTorch, but CipherText adds the magic that allows you to do encryption and all the fancy stuff. So you create your model, which in this case, just like fully connected network followed by a ReLU. The reason I don't use softmax, which we use normally for classification, just for some features that were not available in PySift at the moment of creating this tutorial. Many of them are available now in the new version for the encryption mode, encrypted mode. The classifier, you encrypt the classifier. So this is, of course, not a PyTorch thing, and this is like added by PySift. You encrypt it with SMPC. You create your optimizer. I'm not going into detail. This is the way you, like, not very specific to CipherText or PySift, only this, like this encryption step and fixing the precision of the optimizer. You will learn all about this like when you read the tutorial in details. And you start training. So this is a normal training cycle. You enter the training mode in the classifier, zero out the gradients, forward pass, computing the loss, computing the accuracy, backward pass, optimization step, and logging. And here are some of the results, which are not what's interesting for us today. But if you read the tutorial, you will just see that I create the performance with the stop word taggers and without the stop word taggers and the polarity taggers, and just to show you that it works. Now, a work in progress that you won't be able to execute today, but coming very soon, actually, which is something that will look like this. So this is the step I will skip because this is what we saw, like pre-processing objects. Once you train your model, you will want to add it also to the NLP object. So here, this is detail that is coming soon too. You need to create the object that will, because we don't have data loader for training here, you just want to create another object that will encrypt your vector and communicate with document vectors remotely and get the encrypted version. And you add it. And the interesting step here is that you also add the classifier that you trained, and remote is false. So we consider that this is a valuable model. You cannot just like send it to remote workers because it's private to the company in this case. So data owners should use it remotely, as I showed you in the previous scene, and deploy it. So I think in the version I'm creating, we will call it deploy. You will see it in a few weeks, but this is the idea. Just like call deploy or to grid. This is a decision to be made. And you call your language model something, like sentiment classifier, for instance, and you decide where it should live. So if you have a worker associated to your company called company, just use company, or wherever worker where you want to deploy the model. So finally, thank you very much, of course, for listening. And of course, if you are a developer and this is interesting for you, you are more than welcome to join our team and like to start contributing first before joining the team, of course. And of course, if you're a researcher doing privacy preserving NLP, you're working on a paper, or if you have a company, we are really interested in maybe creating some collaborations together. So please contact me if you would like to create something around your project with CipherText. And of course, if you need to get up to date on like all the new features of CipherText, you can check out my Twitter channel where I diffuse these news. So thank you very much again, and I'm ready for your questions.
Great.
Yeah, so yeah, maybe we can keep the slides in case I need to use them for answering questions.
Great. Thank you very much, Alan. Sorry about my connection went down. So probably I want to ask some questions. First of all, is there any problem if there is, for example, the data set is not the same, for example, from Alice and Bob? So generally, it's not the same, right?
Yeah, this is a very interesting question, and I think there are multiple answers to this kind of question. So, of course, if the two data sets are completely like different, of course, you won't be able to pull them because it will be a different task. But if, yeah, I think Amel is out of connection, but I will like keep answering your question, waiting for her. So, yeah, if it's same distribution, let's say, or we estimate like not same distribution, but like same task, and we estimate that if we combine both data sets into a single data set, we can still train on the same task. Let's say you have two hospitals and both of them have some patient records which have like kind of similar structure, and you want to know if there's like some cancer diagnostic there or not. Of course, you can like use what I showed you and pull them. In some cases, sometimes we talk about vertical federated learning. It means that dataset A has some features of the dataset, and the remaining features are in dataset B. In this case, of course, we need special treatment, and like in order to be like not just like mixing the pointers, we need like more sophisticated treatment in order to create one example out of each corresponding record. Yeah, so I just answered the first question. You can go ahead.
Okay, cool. Thank you. So a second question is basically, someone asked, I found the idea of analyzing text in privacy-preserving settings quite interesting. Could you suggest a few use cases where this could be applied?
Yeah, sure. So in our team, there's a project now. We are implementing actually. So it was proposed by Marcio and currently implemented by Jatin from my team, which is it was a research paper called Federated Learning, two-stage federated phenotyping and patient representation learning, which is a really interesting paper. So you have patient records, and you need to create vector representation of these patients, and then to create a classifier in order to predict some diagnostics. So this is very interesting in healthcare. Many interesting use cases in healthcare. Of course, there are other interesting use cases such as like meta learning. So there's Alex Kerr on, like, if you find him on Slack, is working on this use case. Also named entity recognition. So there's Nilansh from my team is working on this. So in some cases, you need to exclude the entities, like names of doctors. You need to exclude them before any pre-processing. So we need named entity recognizers. And also Sachin is from the team also is working on a very interesting case where if you have like different data sets, and you want to create a language model specific to these data sets, if you don't find off-the-shelf language models, also you need to use this kind of pre-processing, remote pre-processing. So Amel is not here. I'm going to take some of your questions before like trying to take the maximum. Yeah, so, wow, this is a long list. Let me find some. Yeah, so there's maybe quick answer. Alice and Bob, are they running in Python? So the workers we are using today, they are like workers, like the implementation of this worker on Python, but it doesn't need to be. Yeah, so another question. Yeah, so sharing the slides on the codes, actually you can check out the blog post and the tutorials I created, we created actually, the whole team, in the CipherText repository. So you just go to the tutorial part and you will find it. I can also share the slides, of course, after this talk. Yeah, so there was the answer there. Yeah, so can you talk a little bit about encrypted vectors, encrypted training? So encrypted training, this is a large subject, actually. So there are multiple methods of doing this. The method I showed you uses secure multi-party encryption, which means that if you have a training vector, let's say on Bob, you break it into two parts. I'm not going into details, but you break it into two vectors that you distribute to like Bob and another worker, and your model, you do the same, or each parameter tensor is also broken into two parts, and then you do the computation on each worker independently, and then you can actually pull back the results and create, like get your plain text vector. And here I don't mean plain text as a text, like the vector that is not encrypted. We call it like plain text vector. And as I showed you, the prediction, which is encrypted, should be delivered encrypted in many cases, and the worker who sent the request is the one that has the right to decrypt it and get the results back. Yeah, so question here. Let me show if I can show you the question. Okay, so can we find CipherText applications on precision medicine using genomic data? Does that make sense? So, yeah, so while for CipherText, for the moment, what you saw, everything is done for like tokenizing text and working with text. I'm not an expert in genomic data, but I would believe that it's not always text data. So in this case, CipherText would not be the choice for the moment, but this is something like once you create any like library or any representation as like any numerical representation of your object, then you can use PySIF to train the model. So if it's precision medicine or any type of application, it will be like once you have data set and you need to create a model, then yeah, you can use CipherText. Let me search for other questions while Amel is back. Okay. So I do not have access to your offline submitted questions, so I'm going to pick up questions here. If I find some, I'm reading the whole thread. Yeah. So without literally seeing, let me show you the question from Nikhil. Without literally seeing the data, how do we send a particular command like regex, for instance? So yeah, this is kind of a technical question. So PySIF, actually, it's PySIF that provides the whole, like the infrastructure of dealing with sending and receiving objects over the wire. So if, like in CipherText, let's say the tokenizer, if we need to send a regex, so you have CipherText on each worker, of course, it should be installed, and each CipherText instance is aware of an object called tokenizer. So whenever you define a tokenizer locally, and imagine like one of the arguments is regex, CipherText will take this, PySIF, sorry, will take this object and we simplify it. We convert it into serialized version that can be sent over network. And so all the strings are serialized and sent and handled back to CipherText on that remote part. So CipherText then knows how to recreate this serialized version, including the regex and all other documents, arguments, that you created your object with. And you have your regex in the remote part, the remote worker. Yeah, go ahead, Amel. I just answered some questions. I don't know if you have some questions on Slido.
Yeah, I have asked the other questions on Slido, so I'm going to take the ones from the comments. So a question is, what if Alice and Bob don't want to send their data to a third party in clear?
What if? Sorry, can you repeat that?
Yes. So what if Alice and Bob don't want to send their data to a third party in clear?
This is a very good question. So if Alice and Bob each one of them has data, and if they don't want to send them in clear or plain text, this is what I understand. This is exactly what I explained. It means that you, as a user, as Bob, as Alice, you don't need to send your string remotely for the company to pre-process it or to process, to create any prediction over it. You have your string in your mobile phone, for instance, here, and you import CipherText locally on your machine and you search for language model. CipherText has the ability to communicate with all other workers and to ask them if such a language model exists. If it finds one, it knows that your string is private, so it respects that and it pulls all the pre-processing parts to your machine. So pre-processing is happening on your machine, and in the API we provide nothing leaks. It means that we're working hard not to do this. Your string is not transferred back to the worker, so privacy is kept.
Yeah, cool. Thank you. Okay, another question from the comments again. So can you talk a bit about training on encrypted vectors?
Yeah, so this one I answered actually when you were offline.
Okay,
Maybe I
sorry.
answered everything.
Okay, so did you answer then again, can we find CipherText application on precision medicine using...
Yeah, I answered this one. I'm not sure I answered everything.
Well, okay, perhaps I have a question. So if, for example, so basically PySeft and CipherText is, we're going to do the pre-processing on normally English. Does it include other languages?
I didn't understand.
On English, yes. So basically, we're going to do the pre-processing part on English dataset. Does CipherText include other pre-processing for, I don't know, Arabic, Chinese, or any other language?
Not yet, not yet. But of course, this is something interesting we should at some moment work on. But yeah, not yet. Actually, for the moment, to give you maybe an idea of what's going on now, and if you are interested, of course, you can contribute to that as developers. So I showed you the pre-processing part. So the main priority today is the other use case to deploy. So we will be able to, let's say, you create your model and you want to save it. So as I showed you, you call deploy. But imagine that you know of a company that has a very good cancer detector, for instance, and there's another company that created an awesome named entity recognition in the medical field. So there's this model here and the other model there, but they do not live in the same deployed model. So they are in two different models, but you would like just to look at this model and just to pick the cancer detector, and from that model to pick this. So this is actually something that will be available very soon. You just create the pre-processing you want, and then you like shop for models, and you create dynamically pipeline. You look at existing pipeline, and you just connect parts of these pipelines to create whatever pipeline you want on the fly. Yeah, so I hope this answered your question, Emma. Yeah, do you hear me, Amel? Yeah, maybe there's another connection problem here. So, yeah. Okay, so I think, well, Amel is having some connection problems. We arrived at the end of this talk. So I'm really thankful that you listened to my talk. I'm really sorry for Amel that I'm going to finish this talk because, oh, she's here. So I will give her the last word. Let's wait, loading, no. So I'm gonna show you. Okay, so thank you everyone. Amel is almost here. No, okay, so thank you everyone. Thank you for listening. If you have any question, you can just send them on Slack, and either in the Lib CipherText channel, or you can DM me if you have any question, you need any resources I shared here, feel free. So thank you very much, and I need to stop this this talk.